All right, so I'm going to run through this lab one that I, speak to you guys in the class about, and open my command prompt. Here is the process explorer that we spoke about earlier on. I'm going to close this calculator so I can open it and start from afresh. A couple of things here that I have already done. I've already right-clicked this column and I've enabled base address, so I can be able to see the base address for my DLLs that are running over here. I've also enabled, come over here to view, go to lower pane, and then check this DLL, so that way we have this box here to show my DLLs. If I had selected these, what I'll be seeing is the handle, but for this particular session, I just want to be able to see the DLLs, and here is it. So the goal of this workshop is to plant a seed, and that seed is to let you understand that shellcode has a place in our defense toolbox. The goal is not to learn how to write a shellcode. That's not the focus of this class, and it's not to present a complete ontology of a white hat shellcode. I'll just kind of run you guys through a few examples to help you be more creative and give you a kind of a basic fundamental understanding of shellcode and how we can use it and employ it as part of our defensive techniques, and that will kind of help us to kind of practice our defense in depth. All right, so generally speaking, shellcode is almost always used in attack scenario. Most people are familiar with it. Generally, the word shellcode generally kind of bring a kind of more offensive mindset to mind, and that's very common. But in this kind of class, we're going to be looking at it from a more defensive point of view. Shellcode is simply just a tool, and it can be a solution to a problem. So one of the things that I've done in the previous lab, as you might remember, is I walk you guys through a couple of our installation over here. We install Python, and then we install Bandwidth 32, and then we install the network assembler. Here we're going to be using that throughout this class, and I hope that you already have all those in place. The first thing I'm going to be doing over here is to demonstrate how to inject a DLL, a dynamic link library, into a process, and I'm also going to walk you guys through how to unload it. Then we're going to go to the second lab that's going to be talking about enforcing DEP, which is DEP. You remember earlier here when I was walking you guys through this example here, and if you go to your process image over here, see we have DEP status. If I uncheck it, so it tells you can remove it, you can enable it. We'll talk about it a little bit later in depth, but that's going to be in my lab 2. All right, so I believe your environment is already well set up and you are kind of ready to go. I've already launched my process explorer, and I can close it just to kind of start from afresh. I have my workshop fold files over here. Here's my process explorer. Kind of have it open over here, and then I'm going to go ahead and open my calculator, and you can see calculator open up here at the bottom here. And one of the things I'm going to do here is I'm going to inject a DLL into this calculator process. Injecting DLL inside a process is a well-known technique for malware authors. The bad guys use it a lot, and they do that to attack an applications. The Windows API does not provide a function to load a DLL inside another process. So how do we do then? How do we go about doing it? There is, however, an API function that allows you to load a DLL inside a current process. That API function is called load library. To load a DLL inside another process, you can achieve that by calling a load library function inside that other process remotely. In other words, there's a load library function inside that running process. You can call that process remotely, and then you will execute inside that process a code that you desire to execute. So the API function, generally referred to as create remote thread, is generally used. Let me see if I can minimize my windows here to kind of show you an example what I mean by that function here. Go to Google here. So I have an API called create remote thread, and you can learn a little bit more about it. You can see, so this will create a thread that runs inside the virtual address space of another process. See that? So again, if I want to load a DLL inside another process, I'm going to leverage an API function to help me do that, and that is load library. When I load a DLL inside another process, I will achieve it by calling the load library function, and I can come over here and show you that. Load library function. Here's the function that I'm going to use. This load library function is what I'm going to use, and this function is running inside the remote process, and then to execute a code inside that, I'm going to have to use this. So I use a create remote thread function to execute the code, but then I'm going to use this load library to inject the DLL. Very, very interesting scenario. So the create remote thread here will create a new thread inside that target process, and will help me execute the selected code with the provided argument. This create remote thread only accepts one argument to the selected code, and of course for our example here it's not going to be a problem because we're going to be just passing just one particular example. Alright, so without wasting any much time, I'm going to bring this back up again. So I've loaded up my calculator, I've loaded up my Explorer here, and if I select this calculator, you can see here are all the processes that are running over here. And one of the things I'm going to do here is to simply use a Python script here, because the advantage of this Python script is to kind of avoid you getting into writing script or writing any program, because it's not a programming class. So this will automatically allows you to grab the necessary argument and parameters, memory address space and so on and so forth. So you won't, for example, you will not need to kind of worry yourself about trying to find out the handle name and the other information here. This Python will automatically grab that for you. Okay, so the next thing I'm going to reference here is my calculator, and I will then reference the library where this function is located, and it's kernel32.dll, and the function that I want to use to inject DLL is load library. That was how we talked earlier on. And there are two options here. I can either use ASCII, in which case I'm going to have to put over here. I can use white character because I'm specifying the strings here and it's in ASCII. I'm going to use load library A, and I'm just simply going to use str to specify the string and then specify the path for this particular file. It's going to be workshop, and here is the file that I'm trying to reference here, MSG box. So I'm going to type MSG box .dll. So here is the file here. Create more thread, enter my calculator, the process that I want to inject into. Then I want to use the load library to inject the DLL, but I've got to reference the library where this load library function is located. Then I have my str, which is for strings. Where is the part of the strings? I have MSG here, and that's pretty much it. Then I'm going to try and press enter. Let me see this one here. I want to make sure that I got this one properly. So make sure I didn't type something wrongly here. Calculator, kernel, shellcode.dll, load library. Straight again. Alright, now it works now. So you can see I've injected this DLL now into this calculator. You can see over here the DLL that I injected when I select this calculator here. So this calculator here now, you can see, I'm going to click OK now, and you can see that just pop up as a drop box here. You can see the DLL that I now injected into the process of this calculator. So that's how the bad guys will inject, malicious, DLL inside a otherwise benign running process. Now, I'm going to, this is just one example for us. Then the next thing is I can remove it. And to remove it, we're going to leverage another function, which is kind of like a twin pair of the load library. The advantage of that is, it will allows us to remove this particular process from the memory, and the name of the function is free library. So generally I will type come over here and go to my free library, see if I can alright, so here's my free library here. So I go to create remote thread, call the calculator. Free library and load library, they are in the same library, which is kernel32.dll. Remember, load library and free library, they are function, even though they have library in front of their name. So then in this case, free library doesn't accept string. It's an argument here. You have to specify the address, the memory address of the DLL that you want to remove. And in this case, you can see here the address is 0x AF1234. And if I want to, if I press enter here now, you can see I removed it and the MSG box is gone. This message box DLL that we have over here earlier is now gone. So I use load library to inject it. I use free library function to remove it from the process. Now all we've done right now is to use DLL. We have not used any shell code at all. Going forward now, I'm going to go ahead and use a shellcode to demonstrate the same process. So first of all, I'm going to go back and I'm going to go ahead and inject the DLL again into this. So go back. I've injected the DLL over here now. So I'm going to go ahead and create a shellcode and show you how to use shellcode to achieve the same. Alright, so we'll see how to achieve the same result with shellcode. Remember, I use a free library function to unload the DLL that was injected. So without wasting any much time, so we're going to create a shellcode. Again, to make sure that we want to simplify this, there is a Python script that will help you to generate a shellcode. Alright, and then we're going to have to create an -o, which is to specify where the output file is going to be located. Alright, so I can say -dll.asm, alright, this assembly language. So what this Python script is going to do is going to generate assembly language code. Okay, it's going to generate an assembly language code, and I'm going to specify the library to use, which is going to create a link along this part. So I'm going to go ahead and specify the instruction that I want to use for the assembly code, and I'm going to specify the kernel because I'm going to use a free library in the code. So, and I'm going to come over here, free library, and here I'm going to specify the path, the base address of the DLL that I want to unload. See over here. So this message box over here, I've got a message box DLL. So I'm gonna have to come over here and type 0xb12345. I hope I'm getting this right. There you go. I think it's 5 B's, and I'll code it. So let me run through this again just to show you what I'm trying to do over here. I'm using a Python script that is going to generate assembly code. I'm saying -o, the output of this script should be stored as unload.dll.asm, and then here is the argument that I'm parsing into this, for this script to generate this assembly code. Remember, this is assembly code, not a shell code yet. I'm going to use this assembly code and run it through network assembler to generate a shell code. This is just a assembly code, and I'm going to use network assembler to generate a shell code. What you're having over here is just the instruction argument that I'm passing into this code that is being generated at this point. All right, so I'll press enter here, and if I come over here, I can say I will see if I have something over here. Unlimited. 1 second here. So this is the file that I created just recently now. Okay, so then the next thing that I'm going to do here is I'm going to open up my network assembler here that I created earlier on, that I installed. So from this network assembler, I'm going to go over here, and I'm going to go to workshop, press enter, and I'm going to run network assembler. I will try, let me see if I can install increase the font here so you could see that a little bit more clearly. So now you can see, so I'm saying network assembler, and I'm going to say create an output, that's O, and I'm going to say convert this to binary. Make the output to be a binary. So here is the command here now. I'm running a network assembler here against this, assembly code to generate a shell code for me. So if I run this here, so what I have over here, if I can let me see if I have something over here. So you can see I have this assembly code here, but here I have a shell code. So the next thing that I'm going to do here will be I can come over here and run create remote thread calculator.exe, unload binary, and you can see it killed off the message box is gone. That DLL that was injected here earlier is now gone. So what have we done here? What we did over here, we essentially create a shell code here, a shell code, an assembly code here, not a shell code, an assembly code here. We run a Python generator to create a shell code. We save the output of it over here. We pass this instruction. In other words, we're telling this code and say, hey, here is the function I want you to run, and here is the address I want you to target. Generate this output for us. Then we came over here. We convert the shell assembly code, this one here, ASM here, into a shell code, having compiled the instruction over there. And you can actually even test to see what is inside that. If you type a notepad loaded ASM, you can easily see the content of these. This is what a shellcode really looks like for the most part, and you could see and I don't want to get into assembly code language yet, but most of what it's doing over here is preparing the environment, setting up the environment for kernel 32, loading some instruction and pushing some information onto the stack, the kernel 32 function strings, number of functions rather, the hash lookup function, and then before finally calling this library, and then finally when it's done, return, and you can see it pushed this address onto the stack. So when free library function was called, free library function was passed with this address, and then you call kernel 32 free library, get the address that's already posted over here. That is why it killed it. Essentially, we use shellcode to do the same thing. We wrote the shellcode. The shellcode we ran, we already provided it with this address, and that is one of the function of the work what I was doing here earlier on when I was typing kernel 32 free library this. That is how this shellcode knew the address to target. Alright, because I provided it over here, and I already said kernel 32 free library. You can see kernel 32 free library, and this get EIP plus EBX. That's how it got this address. So you say kernel 32 free library, grab this address over here and execute it, and after that return the value. So just want to kind of show you an example of what we've just done to leverage shellcode. The result is the same, but the technique that we have used is different. Instead of using the shellcode library that we used earlier, instead of using the free library function directly with the create remote thread, we simply didn't do that. We went by generate a shellcode that calls the free library and inject this shellcode remotely. Then the question is, why would you want to go through this extra step to include the shellcode? Well, in this example, there's no reason, but you will see example subsequently later that will let you know or demonstrate why shellcode is an important part. And with this, we've come to the end of Lab 1. Thank you.